Hey, Cole.
Hello.
How are you today? I forgot. I looked at my calendar and I saw it at 3 o'clock and I said, wow, did I just make a mistake? And then it seemed to me like you had some reason you had to do it at 3 today instead of 3:30.
Oh yeah, I have an ortho appointment at 3,
Oh,
like around 4. So
okay, cool. Well, let's get on it. We left off at 12, which was this question about a quadrilateral where we had 4 angles and the first 3 are equal to twice the fourth. And we figured out how to do that. So now let's talk about a rectangle. If I have a rectangle that has a certain area of 12, what is its perimeter?
um 16 or 14.
Which means
I'm not sure if that.
well, you're close with your logic. Think about it for a second. Okay, so it could be 4 times 3, right?
Mm-hmm.
Which would give you a perimeter of 14. But it could also be 6 times 2, which would give you a perimeter of 16. Isn't either of those answers correct?
Yeah.
So what does the correct answer have to be?
Oh, it cannot be determined?
Yes.
Okay.
I've probably told you this before, but never choose that as an answer. Well, this is the one problem that I've seen where that is the correct answer. Notice that it could also be 12 times 1, which would be a perimeter of 26. So as long as you can come up with 2 different perimeters that have the same area, then that has to be the answer. It cannot be determined from the information given. I mean, you certainly could say it could either be 14 or 16, but it could also be other stuff. But the moment you say it could be 14 or 16, you know this is the answer.
Yeah.
All right, let's look at this one. Hold on. Again, we're in the section on quadrilaterals or polygons, but not triangles or circles. In other words, we're either talking rectangles. I think this is all quadrilaterals, 4-sided figures.
Yeah.
All right, so this is a little bit of a, not really a trick question. It's just lots of parts to it. What's the shaded region going to be equal to, conceptually?
Shaded region 76.
Yeah, well, they give you that. But what is it conceptually? If I were to look at this figure and I would say, what's the shaded region area, what would you say? It's the area of the outside square minus what?
Minus the areas of the inside squares.
Yeah, so let's write it like that. The area of the shaded region is the area of the big square minus the areas of the 2 little squares. Well, we can figure out most of that. First of all, they give us that is 76. The area of the big square is what, according to this picture?
36.
No. This big square.
Oh, the big square. 2x plus 1 squared? Or?
Yes. 2x plus 1 quantity squared. That's the side of the big square. Well, what's the two areas of the two other squares?
9 and 36.
45.
Or 40.
Well, that's 9 plus 36 is 45.
Oh yeah.
So
okay.
now we end up with this equation. Well, I can solve that. It's one equation and only one variable. And the problem says, what is x? So I have to solve this for x. Well, now let's talk about the best way to solve this. Now we're back to algebra. If I said solve that equation, what would step 1 be?
Add the 45.
Okay. What would the next step be?
Square root each side.
There you go. And that's not obvious what the next step is, because a lot of people would say expand that. In other words, square it. You do the exponent first or you do the parentheses first, it doesn't matter, but a lot of people would say square that as the next step, and that is not the next step. Taking the square root is the next step, just like you said. So what's the next line? What's the square root of 121?
11.
What's the square root of the right side?
2x plus 1.
Now what's the next step?
Subtract the 1.
So 10 equals 2x, x equals 5. Now, the only thing I didn't do there that was quite mathematically proper was the square root of 121 is actually plus or minus 11.
All right.
But when you're dealing with dimensions, which you are in geometry most of the time, you can't have a negative dimension. So if you end up with a negative dimension, you throw it out. Okay, if I were to choose this minus 11, now 2x is minus 12 and x is minus 6. When I plug in x for minus 6, I get a negative dimension. So that negative I don't need to concern myself with, and I'll just concern myself with the positive. But notice I really didn't know that until I solved for x. In other words, there's nothing wrong with having a plus or minus 11 there.
Yeah.
The only thing wrong with it is that when you come up with x, you end up with a negative number, and that makes this dimension negative. So that's the problem with the minus 11 answer. So that's why we throw it out. It's not just because it's minus 11 here, it's because it makes this side negative. The minus answer does. So that's why we throw out the negative and deal with just the positive. So x equals 5. This is a pretty good problem, actually. This problem deals with a lot of stuff. It, first of all, deals with shaded region is always subtraction. It's always the large object minus the inside white objects. No matter what kind of shaded region problem you're doing, that's going to be the answer. In other words, if I gave you this shaded region problem, and I said, tell me the area of that right there, well, we don't have the math, we don't have the geometry to figure out the area of that kind of a shape.
Yeah.
But we do know the area of a square, and we know the area of a circle, and we know that that's 1/4 of that. So this is the area, it's 1/4 the area of the square minus the area of the circle. That's what that would be. And that's what all shaded region problems are. And it's good to know that right off the get-go, because you're going to get a lot of them. Shaded region problems are very, very popular in geometry and when you go to take the ACT test. Just always realize that they're subtraction problems.
Right.
Alright, this says advanced, and typically I've been skipping advanced, but you seem to be doing okay. Let's have a look and see if you can do one of these advanced. Hold on. Make that just a little bit bigger. Alright. So this square has an area of 49. This little tiny square has an area of 9. And they want to know what is the square of, what's the area of that?
What you need to do.
First of all, let's work backwards. These problems are always, you want to look at it backwards. In order to figure out the area of this, I need to know the distance from C to F.
Yeah.
If I can figure out that distance, then I'm going to know the area of this square. Well, let's draw a picture here. We know the area, that's 49, so what is each side?
7.
We know the area, that is 9. What is each side?
3.
So what is this distance from here to here?
4.
So now we have this triangle here that's a right triangle. In other words, I know that that's a right angle there. What is this hypotenuse? If this
5.
side is, got it. Now what's the area of that square?
25.
Good.
Eight.
No. In other words, 8 is the area of that little triangle right there.
Yeah.
That's not half of the rectangle.
Okay.
Half of the rectangle would be this triangle.
Oh, okay.
So ABC or ACD is half the area of the rectangle.
Okay.
Well, that little area is not half of the rectangle. But think for a moment. We know that AEB is the same as this area. Question is AEB half of this triangle right here? And the answer is yes, it is. So the area of this bigger triangle would be double 8, or 16.
All right.
Although that probably depends on a theory, or a theorem. In other words, all geometry is based on theorems. And the theorem here is that the two diagonals would bisect one another. So that would be the same as that. And if you go through the geometry of it, you will discover that triangle AEB is half of the area of triangle ADB.
Mm-hmm.
Although we haven't really gone to the trouble of proving that. All right, let's look at 17. I don't see anything here that's too tough that you shouldn't be able to do. The perimeter of the rectangle is 6W. Well, let's let that be Y and that be X. fact, let's go a step further. If one side has length of w over 2, let's just go ahead and call it that. What's the other side? If we can figure out the length of that, then we'll know the area, right? Because the area is base times height. Well, they're saying the perimeter is equal to 6w. Well, what makes up, we'll call this x for the moment, just because we don't know what it is. What would the formula be for the perimeter?
W over
There you go. Go ahead.
W over 2 plus x plus w over 2 plus x.
So that's 2x's and 2w over 2's. So there's my equation that I can write for the perimeter. In other words, this left side is the perimeter, and they're telling us that it's 6w. Well, that's quite helpful because now it allows me to define x in terms of w. In other words, if I subtract w from both sides, I now have 2x equals 5w. X equals 5 halves w. Well, now I can go back and in place of the x, I can write 5 halves w. And now, what is the area based on those two dimensions? Notice that all my answers have a w in them. So it's fine to have both my base and my height in terms of w.
So 5w squared over 4.
Got it. All right, we start with a square. The length of each side of square A is increased by 100% to make square B. Well, there's my 100% increase, doubling it, which means my new square looks like this. And then what I want to do here is either assign numbers or variables to figure this problem out. Because now I have a third square. Okay? Well, let's just pick numbers. We're going to give that a side of 1. We're going to give this a side of what? The square that's 100%, each side is, in other words, this is A, this is B. What is the side of B going to be?
2.
Okay. And now they're saying that there's another square, C, that each side is going to be 50% increase from C, so what must the side of C be? What's a 50% increase over 2?
1, so 3.
You got it. Okay, so that's... Now, the question is, by what percent is the area of C greater than the sum of the areas of A and B? What's the area of A?
1.
What's the area of B?
4.
What's the area of C?
9.
What percent is 9 greater than the sum of 1 plus 4? In other words, we're comparing 9 with 5. How do you increase 5 to make it 9?
100, isn't it 180%?
Yes. And what they're really saying with this question, this is a little tricky, is what does this equal? Well, that equals 1.8, which is equal to 180%. Now, let's back up a second. It's not the correct answer. The correct answer is 80%. Well, notice the question. By what percent is the area of C greater than the sum of the other two? Well, it's greater by 4. And if I take 4 over 5, I get 80%.
Yeah, you're right. Okay.
Okay? And the only reason I can figure that out is they've already told me that C is an increase of 50%. So I went from 2 to 3. I didn't increase by 3/2. It didn't increase by 150%. I increased only by the difference divided by that. So I really increased by 1 over 2, which was 50%. So just by reading their problem, you can kind of understand what an increase of 50% means. And when I go from 5 to 9, if I went from 5 to 10, that would be an increase of 100%. So going from 5 to 9 is a smaller increase than 5 to 10. And so you can kind of work out that the answer has to be less than 100%. But this is a very tricky part. It's not geometry as much as algebra, the trickiness of this question. And it's really a question of semantics. If I say, what have I done when I go from 3 to 9? Well, I've tripled it, but I haven't increased it by 300%. I've increased it to 300%. So the difference is in the words to and by. If I increase this by 300%, well, 300% is 9. If I increase it by 9, I would get the 12. Okay? So if I go from 3 to 9, I've really only increased it by 6. You always divide by your original. So when I go from 3 to 9, I'm increasing it by 200%. I have increased it to a number that is 300% of where it started from. So you see, it's a question of semantics, not really a question of math. It's a question of whether you say to or by. And that's why these are always tricky.
All right.
What is 100% of 4? It's 4. What is 100% increase of 4? 8. All right, let's see. Let's take a quick look at this. I know we only have a few minutes. These are actually very doable. Okay, a rectangle with integer side lengths has a perimeter of 10. Now, what they mean by integer side lengths is that I can't have 3.5 as one measurement. Everything is, this works. 4 and 1 works just fine. And it gives me a perimeter of 10. Or this works. 3 and 2. That gives me a perimeter of 10. Can I have any other numbers? I don't think so. I think that's the only two integer side lengths that give me a perimeter of 10. There's not a whole lot of other options. I can't reduce 1 less than 1, and I can't, which means I can't make that more than 4. So these are my only two possibilities. So what is the greatest number of rectangles that can be cut from a piece of paper with a width of 24 and a length of 60? What the heck?
Why did it talk about a rectangle from their what?
It's a good question. I'm not quite sure I understand this question. What is the greatest number of these rectangles? In other words, we either have this rectangle or we have that rectangle. There's no other possible rectangles. Okay? So now they're saying, well, if I have a piece of paper that is 24 by 60, and I want to cut little tiny rectangles that are either 1 by 4 or 3 by 2, how many can I get out of that? Well, the way to solve this is, first of all, that's divisible by 1 and 4. That is divisible by 1 and 4. And both numbers are divisible by 2 and 3. Which means that no matter which rectangle I choose, the 1 by 4 or the 2 by 3, I'm going to get a perfect fit. I'm not going to have any left over. Okay? So, how do I know whether I want to put a bunch of 1 by 4s in there or I want to put a bunch of 2 by 3s? And what's the best way to solve this?
My instinct is with the 2 by 3.
Well, how about we take the total area of the big rectangle, which is
Divided by the total area
of each one. There's the area of the big rectangle. 6 times 24 is 144. Add a 0 for the 60. So there's my total area. Well, what's the area of that rectangle?
4.
What's the area of this rectangle?
6.
Which rectangle am I going to be able to fit more of them in there?
The 4.
Yes, the 1 by 4.
Okay.
And how many? Well, if I divide that number by 4, I get 360. So I could put 360 of these 1 by 4 rectangles in there. If I divide this number by 6, that's how many of those rectangles I could put in there. In other words, the total area has to be 1440. And that's what you know. And so that's how you solve it. That is a little bit of a tricky one, but not really. But a good place to stop. We'll stop with the advanced questions on the quadrilaterals. Pick up from there next time.
All right, sounds good.
All right, Cole. Talk to you later.
Talk to you later.